All right, ladies and gentlemen, I'm just going to go over an example from this quadratic formula word problem so you can kind of see what I'm looking for on your assignment. On all these problems, you're going to use a graphing calculator to help you answer them. We have that online one, the Desmos one, or you can use your physical graphing calculator, though the steps on that is a little bit different. You may have to look it up. But yeah, on these, you're going to sketch what the graph looks like. It doesn't have to look great, but you do want to label the important points that you use to help you answer the question. And the problem we're going to go over is number two. It's because it's a great example of what the kinds of questions you're going to see on the assignment and how we use the graph to help answer these. So it's about a toy rocket got launched vertically from ground level with an initial velocity of 128 feet per second. And if you put those numbers into your projectile motions equation, this has the feet per second or the feet projectile motion equation. Since your initial height or h of 0 is 0, then there's no extra term there. But we fill these in into our equation. And the first question is asking how long will it take for the rocket to return to ground? And so I'm going to open up my graphing calculator and put in this equation. But instead of h of t, I'm just going to put y. And instead of these t's, I'm going to put x and x. So it's like x squared and x there. So I'm going to put those in to my Desmos graphing calculator. So I'm going to put y equals negative 16x squared plus 128x. You're going to get a graph looking like this. Well, this rocket got launched up. Let me kind of zoom out so you can see the whole graph here. Oh, there. Now we finally got to the top. So this is a pretty steep one. But yeah, here's your graph. And if you click on the top part a couple times, it does show you what the top point is. And if you come down to your axis here, you can double tap at the axes points and it'll actually label those for you. Well, we actually need that second one because the rocket goes up and it comes back down and it hits 0 at when x is 8. That means when the time is 8. And so if I do a little sketch of my graph here, goes up, comes down. Not a great graph, but we got 0, 0 here. I'm just labeling these important points that I use. This one's at 8, 0. And I can't remember what the top one is. Let me get back to that. Scroll, 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 scroll. That's a lot of scrolling. You get to the top, and it's 4 and then 256. Let me get back to that. Here's 4, 256. And I'm drawing these important points because I know it's going to come up that it's going to ask me what's the highest point. So how long will it take for the rocket to return to ground? Well, it starts at a height of 0 at 0 seconds and then hits the ground, being a y value of 0 again, when x is 8, meaning the time is 8. So that's going to be after or at. Well, because it's asking how long. It's just going to be 8 seconds because that's when it hits the ground at a height of 0. Next one, after how many seconds will the rocket be 112 feet above the ground? This is a slightly different question and actually requires us to graph another line. This 112 feet, well, that's here somewhere, and we need to figure out where that is. So I'm going to go back to my calculator, and I'm actually going to add another equation. And this one's just going to be y equals 112. So it's going to give me should give me a graph. What's all this step business? Oh wait, I just need to scroll down. There it is. I was not paying attention there. Yeah. So if I see my whole graph, then I see this horizontal black line, and I can turn it on and turn it off. But that's the height of 112. If you want to figure out, oh my goodness, I am totally messing up this graph. Figure out where it is. You can kind of zoom in, and if you double click on those intersections, it'll highlight it for you. So we got one at 1 second, it's 112, and this other one is at 7 seconds, it's 112. And so those are the intersections. I'm gonna draw this here, and I have a point here at 1, 112, and then I have a point here at 7, 112. So this rocket's gonna reach that height at 1 second and at 7 seconds. And so this actually has two answers. I'm going to write 1 second. I can spell second. and second. 7 seconds. So those are the 2 points where it reaches that height of 112. And then C asks, how long will it take for the rocket to reach its maximum height? We actually found that already. You can just double click at the top of your graph, and it will highlight your maximum, which is at 4,256. The 4 is the time. Remember, x is time in this case. So it's going to take 4 seconds. And then it asks, what's the maximum height? That's the maximum height there. That's the 256. And you should probably put a unit on this. This is in feet. And so we're going to put this as feet. And ta-da! That's how you do most of the problems. A lot of them don't have 4 parts. They have like 1 or 2. And so you graph it on your graphing calculator. And then you can find things like when does it hit the ground? That's when y is 0. If you want to figure out a certain height, you'll have to graph a second line and figure out the intersections there. If you want to find the maximum, you just scroll to the top or zoom into the top, and you can double click on the top and it'll give you your maximum. And there you go. Enjoy!